So once you've decided if something is an acid, base, salt, weirdo, or none, the reason you're classifying it in that way is to decide, when I write this chemical formula down, should I write it as the chemical formula, or should I write it as the component ions or particles that compose it? So if you look at your instructions here, it says once you've decided the category of compound, you're going to use the rules below to decide if the substance dissociates. The substances that are listed below do dissociate into ions in aqueous or water solution. Now, weirdos are an exception, and this is why they're called weirdos. They do dissociate, but they don't dissociate into ions. They dissociate a little bit differently. So once you've classified something as an acid, base, salt, weirdo, or none, this looks like it is going to work well today. These things do dissociate. Strong acids. There are 6 strong acids. HCl, HBr, HI, HNO3, HClO4, H2SO4. And if you want to go back and add the names of those in there for any ones you don't particularly know, like I hope you all know hydrochloric acid is HCl. And that's why I listed these 3 together. This is hydrochloric acid, hydrobromic acid, hydroiodic acid. HNO3 is nitric acid. HClO4 is perchloric acid. H2SO4 is sulfuric acid. So once you've classified a material as an acid, and then you ask yourself the question, well, should I represent this as ions or not? If it's one of these 6 acids, it gets represented as ions. Otherwise, it does not. Aqueous salts we're going to talk about in a little bit. For aqueous salts, you have to use the bottom part of this page. Okay, so that's why I told you you'd have so many salts to practice with, because there's a whole half a page of rules about looking at salts. Okay, then you have W stands for weirdos. Remember, your 3 weirdos were H2CO3, which rather than ions will become water and carbon dioxide. H2SO3, which will become water and sulfur dioxide. And NH4OH, which will become water and ammonia. Now, you only use this classification. This only happens when the weirdo is produced by a double displacement reaction. So if the hydrogen carbonate or ammonium hydroxide is a reactant, you don't change it into this. It's only if during the course of a double replacement reaction you make one of these products. H2CO3, H2SO3, and ammonium hydroxide can never be the product of a double replacement reaction. They're unstable products in that situation, and they always decompose into those products that you see. Okay, the final S is for strong bases. The strong bases are the following. All group 1 hydroxides. So if you look at the periodic table up there, remember, hydrogen, although it's in group 1, is not really in group 1. It's the weird exception. So it would make water, and water is a none. It's not really a base. So lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium, cesium, and francium hydroxides. All of those are strong bases, and if you put those in water, they dissociate into their component ions. There are 4 more that we will concern ourselves with. If you look at group 2, all group 2 hydrides are strong bases with the exception of beryllium and magnesium. Thank you, Tanner.